In the previous lessons, we learned how to prepare a solution using a specific amount of pure water and solid solutes that we basically measure using our scale. Now, in this lesson, we are going to learn how to prepare a solution at a specific volume using another concentrated solution of that same chemical. So let's look at this problem. A student would like to prepare a 100 milliliter solution that has a concentration of 0.2 molarity HCl. So this is the solution that we would like to make. Using a bottle of a stock solution, this is where we purchased, okay? That contain 50 milliliters of 2.0 molarity of hydrochloric acid, or HCl. So this is purchased. And we are not going to use all of this. So the question is how much of this we are going to use. So to prepare this solution, we need to answer two things. How much of the stock solution are we going to use? We know we're not going to use 50 milliliter of it. And then also we have to ask ourselves how much water do we need to add in. In order to prepare this solution, we have to realize that there is a relationship between two solutions. So in this case, we have molarity 1 times volume 1 equal to molarity 2 times volume 2. And this right here is your stock solution. And this right here is your new solution. So we need to figure out how much we are going to use from our stock solution. If that's the case, that's pretty easy. We can now move this over here, divide both sides by m, okay? Well, m1 specifically. Now we have m2 times v2, which is divided by m1. So the math is extremely easy. And here's the key thing. Look at this. Molarity is being canceled out. So if that's the case, that is extremely important because molarity is being canceled out. We don't have to worry about the volume need to be in liter. This volume V2 and V1, it could be in any unit. It could be any unit of volume. So this is extremely important because molarity is used as a single unit and it's canceled out because M2 divided by M1. So that gives us the ability to have the unit of volume 1 and volume 2. It doesn't have to be in liter, okay? It doesn't have to be in liter. So the unit of V1 and V2 do not have to be in liter. That means it could be in any unit of volume as long as both of them are the same. In this case, what we are using is milliliter. So now let's substitute this in and solve it. What we have here is for M2 and V2, we know that we have 0.20 time or volume of M2, which is 100 milliliter, and then for M1, which is from our stock solution, we don't know how much we're going to use. That's what we are solving for, but we know the molarity, it is 2.00 molarity of HCl. And look what happened. Molarity of HCl cancel out. And now let's plug this into a calculator. 0.2 times 100 divided by 2. And our answer is 10 milliliter. So our volume 1 is 10 milliliter of this solution right here. So this right here is 10 milliliter. So from the bottle of 50 milliliter of 2.0 molar HCl, we only use 10 milliliter of it. And the next step is to figure out how much water are we going to use combining with this 10 milliliter. Well, all you have to do is this right here. You take 100 minus 10 and give us 90. Because using our 10 milliliter, adding another 90, we have 100. So we would have to use 90 milliliter of water. because our final volume is 100 and 10 of it is already from the stock solution, so the rest of it must be 90 milliliter water. Now to prepare this solution, what we need to do is this. We need to add 90 milliliter water first. This needs to be added first. And then we are going to add in 10 milliliter of 2.00 molarity of HCl. And the process of adding water in first is extremely important, because if we have a very concentrated acid or base, no matter how concentrated it is, if you add into the large amount of water, it would be safe. And that's the reason why we add water in first. Always water first, okay? Let's try another problem. A student would like to prepare a 90 milliliter solution of 0.1 molarity of NaOH. So in this case, we only use 90 milliliter, and we want the concentration to be 0.1 molarity. Using a bottle of a stock solution, this is where we purchase, remember. And this stock bottle has 75 milliliter of 0.5 molarity of NaOH left. So again, this stock solution bottle is purchased. But we are not going to use 75 milliliter of it. We only use a small amount of it, combining with pure water. So to solve this problem, again, we have to use this relationship M1 times V1 equal to M2 times V2. And again, this is from our stock bottle, and this is from our new solution. And we don't know how much we are going to use from that 75 milliliters, so we have to solve for it. So V1 is equal to M2 times V2 divided by M1. And all we have to do now is substitute it in. We know our M2 is, and all we have to do now is just substitute it in. So again, our M2 is 0.10, and our V2 is 90, okay? Divided by what? We don't know how much volume we use from our stock solution, but we know the concentration is 0.50. And that's pretty easy. Plug in the calculator. We have 0.1 times 90 divided by 0.5 and give us 18. So now we know that our V1 is 18 milliliters. And this 18 milliliter is of what? Well, it's from the stock solution, 0.50 molarity of NaOH. So right here, this is our 18 milliliter that we are going to use. We don't use 75, but we only use 18. But our final volume is 90, okay? So we have 90, but 18 is coming from the stock solution. The leftover, which all we have to do is subtract. What is 90 minus 18? Well, let's plug in the calculator. We have 72.00 milliliter of H2O. Why is this water? Well, to make a solution or to dilute a solution, we can only use pure water. And therefore, this right here is 72.00 milliliter of H2O. And that's how we do it. How we prepare a solution from a stock solution that is more concentrated. And the same process again, we need to add in the water first. Okay, so in this case, 72.00 milliliter of H2O, and followed by what? Followed by 18 milliliter of 0.50 NaOH. So again, water always first.